Python has multiple data types and data structures that you can use to store and manipulate data efficiently. In this video, we will discuss the Python data type, bytes. Hey everyone, welcome back. In today's video, we're exploring a fundamental Python data structure used for handling binary data, the bytes type. Whether you're working with files, networking, encryption, or raw data, bytes is your go-to. Let's see what it is, how it works, and where you'd use it. In Python, bytes is an immutable sequence of bytes, where each element is an integer between 0 and 255. It's similar to a string, but specifically for binary or encoded data. The B prefix tells Python this is a bytes literal, not a regular string. Strings in Python are sequences of Unicode characters, great for human-readable text. But when you need to store or transmit data in raw binary format, like reading a file, sending data over a network, or working with cryptographic functions, you use bytes. Bytes is the default type used by binary files, and it's the standard for working with protocols like HTTP, TCP, or image and sound file formats. Use bytes when you're reading or writing binary files, when you're sending and receiving data over a network, when you're performing encryption and compression, when you're encoding and decoding text using specific formats like UTF-8 or ASCII, or when you're interacting with external hardware, APIs, or data streams. It's the core data type behind the scenes in many input-output and system-level operations. Here are some things you should remember. Bytes are immutable, just like string. Each item is an integer from 0 to 255. You can create them from strings using encode, and you can convert them back to strings using decode. Bytes support slicing, indexing, iteration, and many string-like methods. Let's look at some examples that show how bytes work in practice. Here, we create a simple byte using a literal. Note how the B character at the beginning indicates that this is going to be stored as a byte. Once a byte is created, we can access individual parts. Here you can see we access the first byte out of the byte sequence using the 0 index. The result is 104, an integer, but this integer happens to be ASCII for a lowercase h. As with many sequences or lists, we can also use slicing with a bytes data type. Here, we get the characters ELL from the byte as we slice it from the first index to the third. We can easily encode or decode string values to bytes. Here we have the string Python. Using the encode method and providing the encoding format UTF-8, we change it to a bytes. We can change it back again using the decode method of the bytes data type. So here we get it back to our string by using the decode method and specifying that it was formatted in UTF-8 coding scheme. The bytes data type can be used in many comparison expressions. Here you can see an example of using it with an equal comparison and with a less than comparison. Lexicographically, you can see that ABC is less than ABD. As bytes is a sequence, we can use a for loop to iterate through the sequence. We have the byte ABC, and we want to look at each byte in the sequence. So when we print it, we get 97, 98, and 99, which are the ASCII integer values corresponding to A, B, C. So as you can see, bytes are simple but super powerful when working with non-textual or encoded information. And that's your intro to Python's bytes data structure. It's an essential tool for handling data at the binary level, from file I/O to networking, encoding, and more. If you're building systems that talk to hardware, transmit data, or just need speed and precision, bytes is the way to go. So if you found this video helpful, hit that like button, subscribe for more Python tips, and drop a comment with how you've used bytes in your own projects. Thanks for watching, and as always, happy coding!